Alright, so here's to review everything that we talked about today. The first thing we talked about is a population. So a population is a group of individuals of the same species that are living and interbreeding within a given area. We have closed populations where their population size is strictly affected by birth and death rates. So these would be things like zoos and populations on islands. And then we have an open population where not only is it birth and death, but we also have emigration and emigration, or organisms coming in and out of a particular population or area. We talked about biotic potential. So that was if given everything that you needed in order to make sure everybody survived, what your population would look like. Okay, and we kind of give this the letter R. And we talked that there was a bunch of things that affect your biotic potential, like the number of offspring that you have in a particular cycle, how often the offspring survive, the number of reproductive cycles in your lifetime, how many years you are reproductive for, the length of your reproductive cycle, the amount of time between them, and how old you can get and still reproduce. So we have biotic potential graphs, and those look like a J. They're exponential growth because that's what we would expect. Then we talked about a thing called doubling time, and that kind of gives us an indication as to how fast a population is growing, because that's what it is. It's the time that it takes a population to double. In natural conditions, though, we don't get exponential growth forever. What ends up happening is we get this carrying capacity. So our graph will look like this. So we get that J curve, but then it'll hit the carrying capacity, and then we start kind of going back and forth over the carrying capacity in a stable equilibrium, and that part is called an S curve because it kind of looks like a S. So things that control a population, we have density dependent and then density independent factors. Density dependent factors are things like disease, parasites, predation, food, the amount of space, or density independent factors are things like weather, forest fires, those sorts of things. We talked about invasive species, so things like rabbits in Australia and cane toads in Australia, and that those guys flourished because they didn't have any competition, no diseases, those sorts of things. So environmental resistance is when we mix the density dependent and the density independent factors, and those help to control the population or to keep that kind of S curve going. We talked about humans, so our carrying capacity and the fact that we're overshot that substantially thanks to medicine. So, and that people think that our carrying capacity is going to be around 9 billion, and nobody really knows exactly how well that's going to pan out. We have things like our selected species. These guys try to reach their biotic potential. They have young reproductive age, high reproductive rates, short lifespans, large amounts of offspring, little or no parental care. And they often do kind of something that is very cyclic, where they do kind of an increase in the summer, and then they all die off in the winter, or most die off in the winter, so on and so forth. They take advantage of those favorable conditions. In comparison to a K-selected species, these guys have low reproductive potential, fewer offspring. Both parents, or maybe even more, have to take care of the offspring. They take a relatively long time to mature.